All right, these are exciting times. We have one more t-test. This is the fourth and final hypothesis test of this unit. You'll see it takes the same 4 steps as the others. It's just a little bit different than the other tests because this one actually pools 2 different samples together. So we need to understand what that means, and that relates to the hypothesis, which is that the groups are different. We'll conduct one by hand, which, just like last time, I just typed it up for you. And then we'll talk briefly about the interpretation of it. So let's get started here. All right. So this is a lack of creativity on my part. I was not able to think of something fun to do with our heart rates that we've been working with. So I was just looking through the slips, and I noticed this thing where some people in the class, when they wrote their heart rates down on their slips, they wrote them all the way over to the side. I call them leftists because that's all the way on the left side. Whereas others, you can see, they wrote it in the middle, and I call these people the centrists. And I didn't know if that's because there was some kind of difference in their heart rates. Yeah, I know it's a really bad idea, but we're going to do it anyway. The only reason anybody would want to study this is just to see how you do a t-test. All right, but first, why is this independent samples? Remember that when you do a 2-sample t-test, it's easiest just to do independent samples. So I'm going to kind of start with the assumption that it's independent unless I know someone's gone out of the way to match these up. I know it's not repeated measures because these are different people. Each person only contributed 1 slip. And if I sampled this slip right here, that has no bearing on which slip I might sample over here. There's no connection between any of those. So these are independent. All right, so let's run through, kind of make a cheat sheet here, and I'll stop at the end of the slide and give you a chance to scribble some things down. But the very first thing is that our hypotheses here is that there's no difference between the groups. And formally, it's been written like this, mu1 minus mu2. So that would mean the population of leftists minus the population of centrists would be 0. Now, what that really means is that they're the same, okay? So the reason it's written like this in most cases is to remind us that the sampling distribution that we're working with is a distribution of differences. Now, in the 1-sample population, or the 1-sample test, we were comparing individual scores averaged together against a population mean. Well, here, under the null hypothesis, where there is no difference, the difference between our sample means should be 0 or very close to it. So that's what the distribution of differences is. Notice here on the alternative side, I put the inequality sign. And in any of the 4 tests that we were looking at in this unit, you always have the option to do a directional test. So this might be how you would write out a test that group 1 minus group 2 is greater than 0. That's if you think group 1 is going to have a greater score. Or you could say 1 minus 2 is less than 0 if you think 2 is going to have the greater score. And you can do that in situations where you have like some sort of prior experience or prior research tells you it's going to move in one direction and not the other. But as far as I know, nobody's ever looked at leftist versus centrist before. All right, let's take a look at critical values then. Because we're dealing with differences between 2 groups, we actually have to do what's called pooling everything together. And the way we do that with degrees of freedom is we just take the degrees of freedom from each group. Now, in my study, I took equal sample sizes, but note that the reason this isn't just degrees of freedom times 2 or something like that is because it is possible to have different sample sizes. All right, in step 3, there are a couple extra steps this time because we have to go through the pooling process and finding the standard error before we get to the test statistic. So we'll go through this step by step in our example, and these are the formulas that we will be using. Finally, at the end, we decide if we reject the null hypothesis or not, and that's followed up by Cohen's d. I'll pause now and let you take any notes you want from the screen. Okay. Now, we're going to run through our example. Again, our example is a pretty lame idea that maybe there's a difference between leftists and centrists. So when I wrote out my hypothesis here, I wrote it out the formal way, where this is reminding me that what we're testing is actually if the difference is 0. I'm using the subscripts here to write myself a note to say that this is the left group, that's the centrist group. Over here, I've just shortened it to L and C because I think I'll remember it. Okay, so for the critical value, again, we're pooling the groups together. I took a sample of 5 leftists and 5 centrists. Degrees of freedom then would be 4 and 4. So when we add those together, we get 8. We'll step away from this and go to the t-table. I'm going to do two-tailed alpha 0.05. 8 degrees of freedom. We'll look in the table, it gives me a 2.306 critical value, and that's positive or negative because it's a two-tailed test. All right, so I wrote that down there. T-crit is 8 degrees of freedom is equal to plus or minus 2.306. All right, so in the right here, I put the X values for my leftist sample and my centrist sample. And as you can see, I've set it up to do the calculations for sums of squares with that X squared column there on each side. And these boxes are down here. I'm just going to put the descriptive statistics for each group down there. That color coding is just to help us keep track of things on a crowded screen. All right, so going through the leftist group, square all the values, sum of X and the sum of X squared. Do that for the centrist side over here. Sum them up. And now I'm ready to calculate sums of squares. So I used calculate the mean first. Notice that the leftist group has lower scores than the other group by 4 beats per minute. I doubt that'll be significant. Okay, so I used my sums of squares formula from that previous page and calculated the sum of squares for each group individually. It's important to do that separately. And then for descriptive statistics in my write-up, when I write about this, I wanted the standard deviations, so I got those as well. It's just the basic standard deviation formula, which is the sums of squares over n minus 1. All right, so that was the top row. That's just getting us set up. Now we're going to start combining things. So we're going to do pooled variance first. Remember, variance is the sums of squares over degrees of freedom. Here, if you look at that formula, what we've done is we're just pooling the two sums of squares here for the numerator, and we're pooling the degrees of freedom. That gives us 18. So that's the variance of both groups combined. We use that to calculate standard error. This value right here is the standard error of the mean difference. Remember, that's not actually any kind of formula. It just says the difference. That value comes out to 2.68, and that goes into our t-test down here. And you can see our t-test is negative 1.64. Just real quick, notice that it's a negative number. I could have just as easily put centrist on the side and left us over here, and I would have come up with a positive value. That's not a big deal. The only time that matters is if you're doing a one-tailed test. You have to make sure you keep track of which side is which so you can create the correct hypothesis. All right, well, we're about done. We're at the decide and interpret stage, and my decision here is fail to reject the null hypothesis. If I sketched out that curve, what I would have is a mean difference of 0 under the null hypothesis and a 0 t-score right in the middle. My critical value up there in step 2 So it tells me that my confidence interval for the difference is between plus and minus 2.306. My t-value is only 1.64, so it's going to fall there in that confidence interval. It's in the null hypothesis region. So we're not able to reject the null hypothesis. That means these groups don't appear to represent different populations. There are probably no real differences between the groups. Although we might be committing a type 2 error. I mean, we do have very small samples here. I'm going to go ahead and calculate Cohen's d, which is 115, which suggests that it's a large effect. But here's the thing. We don't have a significant difference, which means that it's probably just kind of random. We can't really trust that effect. So we can't really think about it too much. So that's it. We failed to reject the null hypothesis. Probably no difference. We still write about it. So this is what I would say. That covers almost all of the results cycle. Just the type of test we did. Showed the descriptive statistics. Said there wasn't significant and explained which group was where by providing descriptive statistics. So that's how it turned out. Now, when I'm done with this, I am, kind of thinking there is a possibility of type 2 error. We did not have a very big sample size. But then again, when I think about the nature of this hypothesis, I really have no reason to believe that one of these groups would score differently than the other. So, yeah, I'll probably accept the null hypothesis as being correct in this case. All right. Hope you enjoyed this one. That's the last of the t-test videos, and the next thing I will do is talk about calculating statistics with technology.